With our understanding of slope, we can use that to develop another very important and useful equation called point slope form of the line. So let's imagine I have some line and I have 2 points on it. One, I have some fixed point, some point that's going to stay right there. That's kind of our point that we know. And then I have some other arbitrary point on the line, some x and y. Notice that I have a subscript on these, but these I do not. Again, the reason why, this xy could be here, it could be here, it could be there, it could be anywhere on that line. So given where I have a fixed point and some other point on the line, what's the slope between those 2 points? Well, remember, slope was my one value of x minus the other one. So in this case, my y minus a y1 over my x minus an x1. Then I could solve that or rewrite that around so that I would have, let's go ahead and eliminate the fraction by multiplying both sides by an x minus x1. And then what I have is I have x minus x1 times m equals y minus y1. And I'm going to just flip it on so the y's are on the first side. So y minus y1 equals slope, or m, times x minus x1. And this equation right here that we derived with the use of the slope, where I have one fixed point and some other point on the line, gives us point slope form of the line. So let's use it to see if it's useful or how useful it is. So here's the situation. I have a slope of 4, and that line passes through the point -1 and 3. So are we able to come up with an equation of that line, maybe in slope-intercept form or standard form? We can if we can use our point slope form to get us there. So our point slope form was y minus y1 equals m times x minus x1. So these are my x1, y1 points. That's the set point that I know that was on the line. So then using this equation, that's a y minus my y1, which is a 3, equals my slope times x minus my x1. And from there, we just kind of clean it up and get it to where y equals. So let's just do it slowly. Y minus 3, 4. Let's do the parentheses first. That makes an x plus a 1. Let's multiply that 4 all the way through. Yep, I got to make sure this 4 is distributed to both of those numbers. And then let's add 3 to both sides. So there's the equation of the line that has slope 4 and passes the point through the point -1 and 3. And if we want to, we could graph that fairly easy. So that's a little bit of how we can use point slope to get us to an equation of a line. And if you wanted to, we can write it in standard form as well, which is subtract y from both sides and subtract 7 from both sides. And that's in standard form. Ax plus b equals a c. If you want me to flip it around this way, that's fine too. And that's in the ax plus by equals c form. So standard form, y-intercept form, and then right here, point slope form. And it was using point slope form that got us to the 2 other equations that we find most useful. Well, this time I'm given 2 points. That's all I'm given are 2 points. And can I determine what the equation of the line that goes to those 2 points? Yeah, we can. And we can do it again by using a little bit of a clever twist on our point slope form. What are the 2 things we need to have in order to use point slope? We need to have a point. Well, we got 2 points, so we have points in abundance. So that's not our issue. But we need the slope. And how do we find this? Oh, we find the slope because we have 2 points. Oh, kind of love how the plan comes together. So let's figure out what the slope is here. Let's make my x1, y1s, x2s, y2s. So slope equals y2 minus y1 all over x2 minus x1 minus 2 minus a 4. And then just kind of clean that up. That was a 3, wasn't it? So 6 minus a minus 3 equals 9 over a negative 6. And that reduces down to negative 3 halves. All right, we have a point and a slope. Now we can use this. So our equation was y minus y1 equals m times x minus x1. Our point, our x1 and y1s, well, you know what? We could use either point. It doesn't matter. Because all I need is 1 point. I have 2. So use whatever one that floats your boat the best. So let's use this first one here. So y minus y1 equals my slope, which is a negative 3 halves, times x minus my x1, which was a 4. There's our point slope form of the line. Well, maybe if I even did this, this might be a little bit helpful if I did it that way. And then from there, let's see what we can do to get it in slope-intercept form, that y equals mx plus b form. So y plus a 3 first. Let's distribute this negative 3 halves to both of those numbers, or both of those contents. So that's negative 3 halves x plus 6 is 3 halves of 4, 6. It is. And then from here, let's subtract 3 from both sides. So y equals minus 3 halves x minus 3. And there we have our slope-intercept form of the line. And if you want, we can put it in standard form as well, having our x's and y's together. So that would be a positive 3 halves x, adding 3 halves x to both sides, plus a y equals negative 3. And that's in the standard form. Both are the right equations of this line. One's just written in slope-intercept form, one's just written in standard form. But to find both of those, I had to go through point-slope form to get there. Some of you guys caught that. I made a mistake on that one. When I subtract 3 from here and I subtract 3 from there, what should I have gotten? I should have got a positive 3. Yeah, that would have made a positive 3 as well. Good thing I caught the mistake before I fired it off to you guys.